All right, so now we're going to try some examples with multiplying exponents, and you can always expand and then count how many of the bases you have, but we're going to try to actually use the rule that we just came up with, which was keep the base and add the exponent. So in example 1, our base is an x, so we're going to keep that x, and then we're going to take our exponents and add them. So up here I'm going to just put 5 plus 3 to show my work and show what I'm doing, and that's going to give me x to the 5 plus 3 is 8th power. So I'm just showing my work so that when I look back at my notes I know how I got x to the 8th power. Alright, example 2, we have this time instead of a variable we have the number 4 is the base. So this time we're going to keep the base of 4, and then you're going to add the exponents. 2 plus 3. So that's going to give us an answer of 4 to the 2 plus 3 gives us 5th power. So 4 to the 5th power would be our answer. And we're leaving them in exponent form. Now, if it said evaluate, we would do 4 times 4 times 4 times 4, but they're not wanting us to do that. They just want us to use our rules to simplify this. All right, and then example 3, we have multiple things here. So we have x squared times y times x cubed times y to the 4th. So to simplify this, we're going to do the same thing. So I'm going to do a little work up here, and then I'm going to finalize it down here. So let's start with our base of x. All right, so I have an x squared, and then to that I'm going to add this x. There's 3 of them. And then I have another base of y, and this y, it doesn't have an exponent. When something doesn't have an exponent, we know there's a 1 there. So I'm going to put 1 plus this y has 4 exponent. So now I'm going to clean all of this up in my final solution down here. So that gives me x to the 2 plus 3 gives me x to the 5th, and then y to the 1 plus 4. So that's y to the 5th. So my final answer is x to the 5th, y to the 5th. All right, and one more. Now this last example, you'll notice we have a number in front of our variable, and this number does not have an exponent. We also have a number over here in front of this variable, and it also does not have an exponent. And you'll also notice that these two numbers are not the same. So these examples is where a lot of students get tricked up. So you want to make sure you recognize, oh, that doesn't have an exponent. So we won't be using our exponent rules for this 4 or for this 2. We're just going to treat these two numbers as a multiplication problem because there is a dot between them, which means to multiply them. So we're going to start by doing 4 times 2. Okay, so 4 times 2. Right, that's just a multiplication problem. They have no exponents, so it's not a keep the base because there's not a base. It's just a 4 times a 2 because they don't have exponents. Now the x's, we will use our exponent rules because they're two of the same bases and they both have exponents. So we're going to keep the base x, and we're going to add these exponents. This is a 3 and another exponent of 3, so 3 plus 3. All right, so down here I'm gonna clean this up. So 4 times 2 gives me 8, and then x to the 3 plus 3 gives me 6. So 8x to the 6th power. All right, now it's your turn. Try the next few problems on the next couple of slides.